In this video, I'll explain Laplace transform of unit impulse function. So first let's see what is this unit impulse function, which is also called as Dirac delta function. It is denoted as delta of t minus a, which is equal to limit epsilon tends to 0 delta epsilon of t minus a, where a is greater than or equal to 0 is greater than or equal to 0. That is, this delta epsilon of t minus a is equal to 1 by epsilon if t is greater than or equal to a, less than or equal to a plus epsilon, and it is a 0 in all other cases. So that is how we define delta epsilon of t minus a, and using which delta of t minus a is defined like this. So the name says impulse. Okay, it changes very rapidly. That's why this function, impulse function or Dirac delta function, is nowhere differentiable. You can just visualize the graph of impulse function or Dirac delta function. So there you can see the graph is changing very rapidly. It has a sharp peaks. The peaks are changing kind of very instantaneous change, due to which you can't get the derivative of the function. So this is how we define Dirac delta function, and the Laplace transform of delta of t minus a is given by e to the power minus as. There we had, in the case of unit step function, this is unit impulse function. This is in the case of unit step function, you had e to the power minus as into f of s to get the Laplace transform of f of t minus a into u of t minus a. Now it is just Laplace transform of this Dirac delta function, which is given by e power minus as. So if a equal to 0, so in that case Laplace transform of delta of t, which is equal to e to the power 0, that is 1. So you have to remember this formula. Let us illustrate this with example. So take up this example. You have to find the Laplace transform of this. You know that linearity property of Laplace transform, you can split it and constant can be taken outside. This equal to 2 into Laplace transform of delta of t minus 1 plus 3 into Laplace transform of delta of t minus 2 plus 4 into Laplace transform of delta of t plus 3. Okay, so this is Dirac delta function or unit impulse function. So this is 2 into, what is the Laplace transform of delta of t minus a? Just now we saw the formula e power minus as. Here a equal to 1. So it is e power minus s plus 3 into, in this case, e power minus 2s plus 4 into, this is e power minus of minus. A is minus 3, so minus of minus plus 3s. So this is the answer. See, next problem, find Laplace transform of t to the power 4 into delta of t minus 3. Okay, we shall make use of the derivative property of Laplace transform, that is Laplace transform of t power n into f of t is equal to minus 1 power n into dn by ds power n into f of s, where f of s is the Laplace transform of f of t. Okay, so what is f of t here? Here f of t equal to delta of t minus 3. So what is Laplace transform of f of t, which is equal to Laplace transform of delta of t minus 3? As per the formula, it is e power minus 3s. So this is your f of s. Now to get the Laplace transform of t power 4 into delta of t minus 3, this formula, n equal to 4, n equal to 4. Therefore, this value equal to, I'll write minus 1 to the power 4 into fourth derivative of f of s, e power minus 3s. So this is positive. So first derivative is minus 3 e power minus 3s. Second derivative is it is minus of minus plus 9. Third derivative is minus 27. Fourth derivative is plus 81. So finally you will get 81 into e to the power minus 3s. This is the final answer. This is how to find the Laplace transform of Dirac delta function or unit impulse function, and using the properties of Laplace transform, we can solve these kind of problems. I hope you understood. Thank you for watching.